Welcome to another video from Explaining Computers. This time I'm going to talk about quantum computing, which sometime in the 2020s may become the most powerful kind of computing available. Stores and processes data. I first made a video on this topic over 5 years ago, and since that time, and particularly in the last 18 months, quite a few things have happened, and so I thought it was time for an update. Now I want to say from the start, this is not going to be a deeply technical video. I'm mainly going to focus on the practical things which are being achieved by companies like IBM. But this said, I thought we should start out with a basic overview
to represent a value of either 1 or 0. Conventional computers subsequently store and process data using based on millions or billions of miniature transistors. In contrast, can be turned on or off to represent a numeric value of 1 or 0. These, in turn, are represented in hardware using to store and process data using binary digits. For example, quantum computers may use the spin direction of a single atom to represent quantum bits or qubits, which are represented by the quantum mechanical states of subatomic orientation. Due to the strange laws of quantum mechanics, qubits can exist in more than one state to allow superposition at exactly the same quantum spin of a tiny magnetic field. This allows a qubit to assume a value of 1 or 0, or both of these numbers simultaneously. Due to the peculiar laws, this enables a quantum computer to process a far higher number of data possibilities than a classical computer. 0, or both numbers simultaneously. The fact that qubits can be in more than one state simultaneously is exceptionally used to represent qubits. Flip a coin exist in more than one state, and it cannot come up both heads and tails at exactly the same point in time. And yet the quantum state of a qubit really can do just a probability to each of these states. A single qubit, in addition to assuming superposition, qubits can become entangled. Entanglement is another quantum mechanical property that means that the state of one qubit can depend on the state of another. This is useful and powerful, as it means that observing one qubit can reveal the state of its both heads and tails simultaneously. And yet the quantum state relying on these strange quantum mechanical properties, future quantum computers should be able to tackle computational challenges that cannot be handled by traditional hardware. Stated that anybody who is such challenges are likely to include molecular modelling, which may lead to medical advancements and the development of new materials. Future quantum computers should also help to solve logistical problems, as well as enabling the development of far more sophisticated deep learning artificial intelligence. Parallel processing. Quantum computers are also likely to be used for code breaking and in cybersecurity that will process data according to the probability of a solution being correct. This means
many large computing companies are now working on quantum processing activities, and indeed IBM has been researching quantum computing for over 35 years.
The first sentient artificial intelligences
in May 2016, IBM made a 5-qubit quantum computer publicly available.
One of the first mainstream applications of quantum computing will be in security and data encryption.
And you can click on Library to access all the
Today,
manuals
all online
and all
security
about it,
systems
or you can
rely
go to
on
the
prime number
tab,
calculations,
and you can actually
at which
access
quantum
a
computers
real working
will excel.
quantum computer.
Quantum
and already this
computers
has been
have
used
indeed
to run
already
over
been termed the
300,000
hydrogen
public
bomb of
experiments.
cyber warfare.
Now, in March 2017, IBM created a new division, IBM
In
Cube,
2007,
which is going to develop
a Canadian
and make
company
available
called
commercial
D-Wave
quantum
announced
computers
the world's
which will
first
access
commercially
over the
viable
web from the
quantum
IBM
computer.
cloud.
This
And
was
in
based on
May
a supercooled
2017,
16-qubit
IBM announced two new
processor made from the
prototype
rare
quantum
metal
processors.
niobium.
A 16-qubit processor
While
which
many
is now
people
available
were somewhat
over the web from
skeptical
its
of
Quantum
D-Wave's
Experience
claims,
website,
in December
and a 17-qubit
2009,
processor
Google
which is going to be the
revealed that it
start
had
of its
been using
commercial
D-Wave's
quantum
hardware
computing
in
ventures.
image
It's still a
recognition
prototype,
experiments
but it'll
with
be
a high
involved
level
in
of
delivering the very
success.
first and very early commercial quantum computing
In May
services
2011,
over the web.
D-Wave
And it
launched a
doesn't stop
1 to 8
there.
qubit quantum
IBM hopes
computer
in time to
called the
develop a
D-Wave 1.
50-qubit processor.
This
And this is
supercooled
significant
machine
because a
is housed within a
50-qubit
10
processor
square
should be
meter
able to achieve
shielded
what's
room
called
and
quantum
priced at
supremacy.
$10 million.
In other words, a 50-qubit processor
first
should be
D-Wave
more
1 has
powerful
already
than
been
any
sold to the
traditional any
US
transistor-based
aerospace and
computer
military
ever
contractor
created.
Lockheed Martin. Other companies, including
Another
IBM,
impressive
are
quantum
also
computing
pioneering
pioneer
quantum
is
computing
D-Wave Systems
development.
in Canada.
In January
In
2011, a team from
D-Wave
Oxford
demonstrated a
University
working
even managed to
16-qubit
quantumly
quantum
entangle
computer,
10
and then
billion
in
qubits
2011
inside a
they
highly
became the first
purified
company in the world to
silicon
actually
crystal.
sell a quantum
The
computer
early
when they sold
foundations
a
are
$10
therefore
million
already being laid
1 to
for
8
quantum
qubit machine called
computers
the
with
D-Wave
processing
1 to
capacities
Lockheed
well
Martin.
beyond human
In
comprehension.
2013, D-Wave Next sold a 12-qubit machine called the D-Wave 2 to NASA and Google,
within 10
who established
years,
a quantum artificial intelligence lab at the Ames Research Center in California.
For more information,
by 2015, D-Wave had broken the 1,000-qubit barrier with its D-Wave 2X, and in January 2017 sold the first 2,000-qubit machine, the D-Wave 2000Q, to a cybersecurity firm called Temple Defense Systems. Now, despite all of these milestones, the work of D-Wave systems remains controversial. And the reason for that is they use what's called adiabatic quantum computing, what's called quantum annealing. And this approach to quantum computing has been dismissed by many others in the field, not least IBM, who call it restrictive. IBM have even called it a dead end. Now, to explain what all this means without getting deeply technical, in an IBM system, they use what's called a gate-based approach. In other words, they actually have control of the qubits in their system. The same way that if you've got a transistor-based computer, you can control the flow of electrons in the transistor. But in a D-Wave system, in a quantum annealing system, you don't have that type of control. So you might be thinking, how do D-Wave actually make their quantum computer work if they haven't got full control of the qubits? And the answer is they take advantage of the fact that all physical systems tend towards a minimum energy state. What does this mean? Well, it means that if I make a cup of tea, it'll be boiling hot, but if I leave it on the counter for an hour and come back to it, it'll be stone cold, or at least it'll be the same temperature as the surrounding environment. It would have tended towards a minimum energy state. And what D-Wave do is they take advantage of the fact that the qubits in their quantum computers will also head towards a minimum energy state. So while they can't actually directly control them, they do know what their behaviour is going to be. And therefore what D-Wave do is they express all the problems they give to the quantum computer, all the algorithms they give it to solve, they express them all as energy minimization problems. And yes, that is restrictive. They can only run certain types of algorithms, but it has allowed D-Wave to create the systems it has to start selling them and to have more qubits than anybody else. But you can hopefully now understand why this is controversial. This all said, there has been some very good evidence recently that the D-Wave systems are functional and useful for certain types of purposes. Not least, this paper was published in 2016, and according to this paper, the D-Wave systems can run certain algorithms up to 100 million times faster than a conventional computer with a single core processor. So that is a pretty good result, and it's worth pointing out that everybody who wrote this paper, who did this research, actually works for Google. Talking of Google, in addition to being a customer of D-Wave systems and having bought several of their quantum computers, Google is also developing its own quantum computing technology. And this is a kind of hybrid between the machines being made by IBM based on a gate-based model and the machines being made by D-Wave systems based on quantum annealing. And right now, Google is testing a 20-qubit machine based on its technology, and by the end of 2017, it hopes to be testing a 49-qubit machine, or in other words, a quantum computer approaching a point of quantum supremacy. Now, the other interesting thing that's happened recently linked to Google is that in March 2017, this paper was published in the science journal Nature, and a lot of the authors of this paper are Google engineers. And I think you can take this paper to be a statement of intent from Google about the importance of quantum computing. This was published in the same month that IBM announced IBM Q, their own commercial quantum computing initiative. And in this paper, the Google engineers are arguing they must invest very heavily in quantum computers because, as they say in this paper, within a few years, well-controlled quantum systems may be able to perform certain tasks much faster than conventional computers based on CMOS or complementary metal oxide semiconductor technology. Just in case you're wondering, Microsoft is also working on quantum computing with an initiative called Station Q. And this is basically backing lots of different quantum computing projects around the world in different labs and also on its own campus. And it's particularly focused on a technology called topological quantum computing. In December 2016, Intel also revealed plans to create quantum computers using silicon qubits inside transistors on traditional silicon wafers. In other words, Intel is trying to make quantum computers work based on the silicon chip technology it obviously knows very well. And a final company I would note is Alibaba. Alibaba is the biggest e-commerce player in China. And in July 2015, Alibaba teamed up with the Chinese Academy of Sciences to form the CAST Alibaba Quantum Computing Laboratory. And as one of the professors involved in this explained, the CAST Alibaba Quantum Computing Laboratory will undertake frontier research on systems that appear to be the most promising in realizing the practical applications of quantum computing. Quantum computing is based on extreme engineering. For example, the quantum processors at the heart of the D-Wave and the IBM systems I've discussed in this video have to be supercooled down to almost absolute zero, down to almost the temperature at which atoms stop moving. And that type of thing is never likely to happen in the home or in most workplaces. So we can be fairly certain that quantum computers will always be constrained to the data center. And in turn, that tells us that quantum computers aren't going to replace all traditional computers. Indeed, nobody in the industry expects that's going to happen. But clearly, what the big computing companies do think will happen in the next decade or so is that quantum computers in the data center will start to complement traditional computers and will allow them to start offering new types of services, new types of security services, new types of scientific services, but also new kinds of artificial intelligence. So it's perfectly possible that maybe in 10 years' time, you'll be having a conversation with a digital assistant, something that's a descendant of something like Amazon's Alexa or Cortana, and that digital assistant will be running on a quantum computer. So in maybe a decade's time, many of us will spend our days talking to quantum computing systems. And so, with that thought, that's now it for this video. I hope you've enjoyed what you've seen here. If so, please press that like button. If you want to know more, I've left loads and loads of links down in the video description. If you haven't subscribed to this channel, please subscribe, and I hope to talk to you again very soon.